Relationship between two entities is nothing but relationship. Many students enrolled for many courses in example for many-to-many relationship. Ordinarily, it will be having minimum relationship because it is not either mandatory or optional. In this table, for all the employees, license number is unique. Similarly, for all the employees, passport number is unique. So these together forms a candidate key. Dear students, welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion. Let us continue our discussion with the concept, database concept, chapter 13. Now, in this session, we are going to learn few definitions of ER diagrams, relationship, and other definitions which are related to database. Now, let us start with what is ER diagram. So, what is ER diagram? Here, ER stands for Entity Relationship Diagram. So, is a visual representation of data that describes how data is related to each other. Now, you know what is a database? Database is nothing but a collection of different types of data. And how do the data are connected to each other? So, that is we are representing visually through ER diagram. That is a definition of ER diagram. Now, first definition is what is entity. The ER diagram has three main components. First one is entity. So what is entity? Entity can be any object, place, person or class. So this is a definition of entity, and in ER diagram entity is represented using rectangle. And look at the example now. In an organization, employee and manager, department, product can be taken as entities from an organization. So here organization, and under that we can have employee as an entity. So what is an entity? It is an object, place, person or a class. Now look at the diagram here. In ER diagram, student, teacher and project. Here these three are different entities or an object. So student, teacher or project, there are three different objects. And what is the relationship between all the three objects? We are representing through ER diagram. So here employee, he works for department. Here we are representing entity through rectangle. So here these rectangle, here in example employee and here department is an entity, and here is the relationship. So this is entity relationship diagram. In the next slide, we will see what are attributes. An attribute describes a property or characteristics of an entity. So this is an attribute, and example name, age, address, etc. can be attributes of a student. So if you look at the previous example here, this is student is an object for us. And so in this example, attribute is the properties of an object or characteristics of an entity or an object here. We are representing through ellipse here. So look at the diagram here, an attribute. Here student is an object here. The student has characteristics like name, birth date or date of birth and roll number. Here this name, birth date and roll number are attributes of an object, student or entity, student. In this example, employee, suppose this is an object here or entity, and name, employee ID and employee age are different attributes of entity, employee. Now in the next slide, we will see what are key attributes, and we in the previous slide we have learned what is an attribute. Now let us see what is key attribute. So key attribute represent the main characteristics of an entity. So here entity, the attributes is, you know what are attributes? and the main characteristics or main attribute of an entity is nothing but key attribute. It is used to represent a primary key in a table. We are going to learn different types of keys shortly. So it is used to represent primary key, and ellipse with underlying lines represents key attribute. So here ellipse with underlining lines. In this, look at the example now. Here student is an entity and it has the attribute name, student address, age and ID are different attributes of entity student. And which is the main attribute here? In this example, ID. So student ID is a unique ID. So we are representing student with respect to his ID. So ID number. So this ID is a key attribute of this entity student. Next definition is composite attribute. What is composite attribute? An attribute can have its own attributes. So an attribute can also have its own attributes, or nothing but composite attributes. So here these are known as composite attribute. Now let us see the example here. This address, the address is one attribute, what you have seen in the previous slide. So here address is one of the attribute of the student entity. So address has different parts. If I say address, so is the name of the city, state and zip or pin code. These are all the characteristics of this attribute address. So these are called as composite attribute here, because address has following three different fields or different attributes. So this is composite attribute. In the next slide, you see relationship. So what we have seen now is ER diagram, that is entity relationship diagram. So what is relationship? So it describes relation between two entities. Now you know what is an entity. So relationship between two entities is nothing but relationship. So it represented using diamond or rhombus. So this is a geometrical shape we are used to represent relationship between two entities. Now here we can find these different types of relationship. One is binary relationship, recursive relationship and ternary relationship. Now let us see what is binary relationship. So here binary relationship means relation between only two entities. This is further divided into three types. So here what is binary? Binary stands for two. So relationship between two entities only. Now look at the example here, and here A and B are two entities. So here one entity, another entity, relationship is between, we are representing with a rhombus or diamond shape. So this is a relationship, and here represent here student and here course, and a student enrolling for a course. So this is a relationship. So here enrolling for a course, a student enrolling for a course is a relationship. So this is a binary relationship. Next, under this binary, we have three different relationship, three categories, that is one-to-many relationship. So it reflects business rule that one entity is associated with many number of same entity. The definition, this is a definition. And here, for example, student enrolls for only one course, but course can have many students. Please understand the concept here. Student enroll for only one course, but the same course has number of students in the department or in the course, that is one to many. Look at the example here. Here A is an entity, B, these are all different entities. So here entity 1 and is an entity, and between this we have n number of relationship. So here one course may have n number of students. So here, for example, student enroll for one course. So this is the one to many relationship, or one course will be having many students enrolled for that particular course. That is an example for one to many. Next one is many to many. So this is another category of relationship under binary relationship. So the diagram, many students can enroll for more than one course. Please know that many to many. In the previous example, one course may have number of more than one students. But here, many student enrolled for many courses in example for many to many relationship. Look at the diagram here. Suppose these are you can take it an example as students, and there are 3 different courses. So each student can enroll for more than one course. So this is an example for many to many. So we are representing like this. So this entity and entity here, and between n to 1 relationship, or this is the diamond shape, represent relationship between 2 entities. This is many to many relationship. Next definition, we will see what is cardinality. Next definition is cardinality. It refers to relationship between a row of one table and a row of another table. The only 2 options are one or many. So here, what is cardinality? Here we know what a relation. Another name of table is relationship, and there may be a relationship between 2 different tables. That is possible through cardinality. So here definition is relationship between row of one table and row of another table. Now cardinality refers to uniqueness of data values contained in a particular column of a database table. So here we are identifying this through one particular field or one unique field. So this is cardinality. It specifies maximum number of relationship. It is possible to have more than one relationship between between more than one tables. That is cardinality. Next definition is ordinality. What is ordinality? So here it describes relationship as either mandatory or optional. So it is not necessary to have a relationship, or it is an optional. That concept is ordinality. So it specifies absolute minimum number of relationship between tables. If you look at this cardinality, it will be having maximum number of relationship between the tables, where ordinality, it will be having minimum relationship because it is not either mandatory or optional. Next definition is generalization. So what is generalization? So in generalization, a number of entities are brought together into one generalized entity based on their characteristics. So I repeat the definition. So number of entities are brought together into one generalized entity based on their characteristics. Now it is a bottom-up approach in which 2 lower level entities combine to form high level entities, and the higher level entity can also combine with other lower entity to make further higher level entity. So look at the diagram here. So here this is pigeon and sparrow, dove. All 3 are examples of entities or individual entity. And if you observe this, pigeon, sparrow or birds, so we can have one entity which is combined the characteristics of all the 3 entity. And here if we talk about birds, pigeon, sparrow, dove, or the birds will be having similar characteristics. We are brought together to form one entity. That is generalization, and it is nothing but it is a bottom-up approach. This is generalization. Next one is specialization. Another definition, another term is specialization. So it is opposite of generalization, and in specialization, a group of entities is divided into subgroups based on their characteristics. So this is the reverse of generalization, where here the group of entities divided into subgroups based on their characteristics. So it is a top-down approach. So if you look at the previous one, it is a bottom-up approach. So this is top-down approach in which one higher level entity can be broken down into lower level entities. And some higher level entities may not have lower level entity as its sets. So this is specialization. Now look at the example here. This is one person. This is a relationship student and teacher. Here, one person, he can be a student or he can also be a teacher. So this is an example for specialization. For another example, in a company, a person, he can be identified as an employee or an employer or customer or vendor based on the role that he plays. So this is an example for specialization. And in a school database, a person can be specialized as a teacher or a student or a staff based on their role. So this is an example for specialization. Next term is nothing but case. So we are going to learn what are case or different types of case with respect to database concept. So here the word case is used in context of relational database design, and they are used to establish and identify relation between the tables. So we are using case to establish a relationship between different tables, and the key is a set of one or more columns whose combined values are unique among all the occurrence in a given table. So this is another definition of keys. By looking at the diagram, we can understand the definition of different types of keys here. Now look at this. This is one table. This is employee table. In the employee table, if you observe this, we have employee ID, name, address, license number, and passport. All are different attributes. And here, these are the different values in a table. So this is one table. And this is another table, employee ID, employee salary month, and amount. This is another table with 3 columns or 3 attributes. And these 2 tables will be having different number of records. Now by looking at this, we will see different types of keys with respect to database. Now let us start with a primary key. So what is a primary key? Here employee ID is a primary key, and here coordinate key, and this is what is employee ID as well as license number as well as passport number or candidate key. And next one is here another license number, passport number is also known as unique keys, and all together it forms a super key. And here foreign key. What is foreign key? So here employee ID is here, another employee ID is also here. So here this is employee ID. So this is a foreign key and this is a primary key in one table. So primary key of one table is a foreign key of another table. Next we have composite key here. So if you observe employee ID, other salaries, and all these together forms a composite key. And alternate key, another key is called alternate key. So by looking at this diagram or these 2 tables, it is easy for us to understand the definitions or difference between different types of keys in database. Now let us see the definition of all the keys what you have seen in the previous diagram. One is candidate key. It is any set of one or more columns whose combined values are unique among all occurrences or in a record or rows. So what is this is candidate key. Here employee ID is unique in a table and license number is unique in this table. For all the employees, license number is unique. Similarly, for all the employees, passport number is unique. So these together forms a candidate key. Next, primary key. Primary key is a key that uniquely identifies each record in a table. So if you look at this here, primary employee ID is a primary key. So we are identifying these records or employee records with the help of employee ID. So it is unique with respect to this table. So this is referred as a primary key. It is a unique key. That is primary key. Next one is alternate key or secondary key. The alternate key of any table are simply those candidate keys which are not currently selected as primary key. So in the previous slide, see here license number, passport number are also candidate key because all these are unique in nature. So here employee ID is unique, license number is unique, and passport number is unique. So out of these three columns, employee ID is the primary key and other two are called as alternate key. Now next definition is super key. It is basically a set of columns for which no two rows share the same values for those sets. And if you look at the diagram here, see here primary key, candidate key, unique key, all these forms a super key because all these have a different or unique value. Next one is foreign key. What is a foreign key? It is a field in a relational database or table that matches the primary key column of another table. So what is foreign key? In the diagram, if you observe this is another table and here employee ID is here, this is also employee ID. So primary key of one table is the foreign key of another table. So we are identifying the table with reference to employee ID. That is the relationship between these two tables. That is foreign key. Next one is composite key. So here it consists of two or more attributes that uniquely identify an entity. Occurrence is called composite key. These are all different types of keys with respect to database concepts. In the next slide, next concept is data warehouse. So what is a data warehouse? A data warehouse is a repository of an organization's electronically stored data, and data warehouse are designed to facilitate the reporting and supporting data analysis. Now you know what is a data. Data is very, very important in the field of computer science. So here data warehouse is nothing but it is a collection of data. So it is a collection of data or electronically stored data in a computer, and is very, very important as far as any organization is concerned or any company is concerned. Data is very, very important. Database is a concept, and collection of different types of data are nothing but, or maintaining a database with respect to any organization is nothing but a data warehouse. Now, what is another points are here? A separate computer databases are designed to support management, information and analysis purpose. So what is the advantage of data warehousing? It is going to help any organization in analysis, data analysis or marketing analysis. These data warehouse were able to bring the data from different data sources, from mainframe computer, mini or personal computer, and office automation software such as spreadsheet, and this information in a single place. Now, the data warehouse, as I told, is a collection of database, and for this data warehouse, all the data are coming from or stored from different resources, maybe a mainframe computer or mini computers, or with the help of different softwares. So data warehouse is generally a collection of data to be having data from different resources. Next, it also has a user-friendly reporting tools. Once the database is available, so it is easy for anyone from organization to generate different type of reports. And it has several stages. Data warehouse, it has several stages. Like first one is offline operational database. This is a type of warehouse. So here data warehouse, offline operational databases. See, this initial stage of data warehousing. Data warehouse in this initial stage are developed by simply copying the database of an operational system to offline server. So what is offline? Nothing but it is not online. So here, how do we start with this? So at the beginning, we are going to copy the working, online data warehouse or databases to another system that is it is not on the server, that is offline server. So this is offline operational database. Second one is offline data warehouse. So in this stage, data warehouse are updated on a regular time cycle, okay, from operational system, and the data is represented in report structure. So what is offline data warehouse? Here very frequently, maybe at regular interval of time, maybe daily, weekly, or monthly, all the data are updated from the online and copied to this offline data warehouse. So this is offline data warehouse. Next definition is another type of warehouse, real-time data warehouse. So here, data warehouse are updated when transaction or event is performed. As and when the transaction takes place, so all the data are updated immediately. That is real-time data warehousing. Next one is integrated data warehouse. So here, an integrated stage, it is not only updates data when a transaction is performed, but also generates a transaction to pass the data to the sources. So here, this is a communication or transaction between different systems, that is integrated data warehouse. Next, we'll see what are the different components of data warehouse. First one is data source. What is data source? It refers to any electronic repository of information that contains data useful for management and analysis. So here, the data of a data house is collected from different sources. So that is what you have seen. If I say data warehouse, so first up is data source or data collection. So data source. So we can have data warehouse can have different types of data from different resources. And here, next one is data transformation. The data transformation layer receives data from the data source and it cleans, standardizes and loads into the data repository, or that is a data warehouse. See, what is data transformation? It is nothing but cleaning the data. It is possible to, we are getting the data from different resources and that may not fit into the standard of this data warehouse. So here the step is transformation. Means nothing but we have to clean, or we have to make the data to fit into the particular standard, that is data transformation. Next one is reporting. So data in the data warehouse must be available to the organization's staff, then data warehouses will be useful. So whatever the data available in the data warehouse of any organization or any company, it must be available to the staff for reports or to generate different types of reporting to the concerned people in any organization. That is reporting. Next one is metadata. So what is the definition of metadata? Metadata is nothing but a data about data. It's used to inform about the status of data warehouse and about the information held within the data warehouse. So this is data about data is metadata. Next one is operations. See, what are the operations on data warehouse? So it consists of operations such as loading, manipulating, extracting the data, and all these are different types of operations can be performed on database or data warehouse. And it also operation also covers user security and related function. So any data adding, updating, manipulation, extracting data within a warehouse are nothing but operations on data warehouse. Next, let us see what are the advantages of data warehousing. One, it enhances the end user access to reports and analysis or information. So here the user can access the reports and analyze the data by different types of people in any organization. Increase data consistency and increase productivity and decreases computing cost. Right, able to combine data from different sources in one place. See, that is what is called as data warehouse. And data warehouse provides an infrastructure that could support changes to data and replication of the changed data back into the operational system. So these are the different advantages. Now let us see what are the drawbacks of data warehousing. And extracting, cleaning, and loading data could be time consuming. That's what you've seen the components of data warehouse. That is data transformation. That is, it is a time consuming, it's a tedious job. And it get outdated relatively quickly, as it is the data warehouse. The data in a data warehouse, it will be outdated quickly. Next one is problems with the compatibility with the system already in a place. So another drawback is that any data comes into it, it should be compatible with the existing data warehouse. Providing training to end users, and here as and when it is necessary for the users to be trained effectively to use the data warehouse effectively. Next, security could be serious issue, especially the data warehouses is internet accessible. So anything with respect to internet or internet accessible, it will be having a security issues. See, these are all different disadvantages of data warehouse. Next concept is data mining. So what is data mining? And all of us are familiar with the word mining. You say gold mining or coal mining. So here this is almost similar to that. This data mining, it is electronic data mining. So here it is concerned with analysis and picking out relevant information. So this is data mining. It involves collection or picking of the information within the data available. It is the computer which is responsible for finding the pattern by identifying the underlying rules of the features in the data. So what is data mining? Actually, we are looking for a particular pattern or a design with the available data. That is data mining. In the next slide, data mining analysis tends to work from the data up, and the best techniques are those developed within an orientation towards large volumes of data, making use of as much of the collected data as possible to arrive at the reliable conclusion and decision, and to get the required pattern within the available data by using different techniques or the best techniques available for data mining. Some of the data mining softwares are SPSS, SAS, Think Analytics, and GSAT are few examples of data mining software. In the next slide, and what are the advantages of data mining? So here, market analysis and management, that is important. Corporate analysis and risk management. By looking at the data mining, it is possible to data analysis with respect to market and corporate level, and fraud detection, production control, and customer retention, science exploration, sports, astrology, and internet web surf aid. All these are different applications where we are using data mining. Next, we'll see what are different phases of data mining. So it starts with the selection. First one is selection. So selecting or segmenting the data according to some criteria all the people who have won a car. See, this is an example here. What is the first step in data mining is selection. We have to select the appropriate data according to our pattern or design. Next step is pre-processing. So it is the data cleaning stage. So where certain information is removed which is not necessary or unnecessary. So this is the pre-processing, means once the data is collected or within the data, next step is we have to clean the data or nothing but removing unwanted information within the data. The next stage is transformation. So the data is not merely transferred but to be transformed. So this is one more stage. In the next slide, we will see data mining. So data mining, this stage is concerned with extraction of pattern from the data. So here next one is, see, with the help of this, there is a data available here, and within the data we have to get the appropriate design or a pattern, that is data mining. And interpretation and evaluation. Next stage is this. So here the pattern identified by the system or interpreted into the knowledge which can be used to support human decision. So here whatever the design or the data mining product we get from on this stage, and it has to be interpreted to the user effectively. So that is interpretation and evaluation. Otherwise there is no meaning of data mining. So whatever the data mining result, the pattern what we get from this stage, it has to be conveyed or transferred to the users with knowledge. That is very, very important stage. Student, so far in this session, we have learned few definitions, concept with respect to database. Let us continue our discussion in my next class. Thank you very much.